March 17, 1944, 11:42 a.m., 28 Zewazuren feet over Schweinfurt, Germany. Lieutenant Robert Bob Johnson pulled his P-47D Thunderbolt into a near-vertical dive, airspeed indicator screaming past 500 miles per hour. Below him, a Fokker Wolf 190 twisted desperately, trying to escape. Johnson's aircraft shuddered violently but held together. The German pilot looked back, saw the massive American fighter still accelerating downward, and his face went white with disbelief. At that speed, his own FW-190 would have torn itself apart. Johnson's 8 .50 caliber machine guns opened fire at 400 yards. The German never pulled out of his evasive turn. Before we continue with Bob Johnson's incredible story, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now, back to Schweinfurt, where Johnson was about to discover just how much punishment his Thunderbolt could absorb. What the Luftwaffe pilots didn't know, what they couldn't believe even when they saw it, was that they were facing something unprecedented in aerial warfare. A fighter plane built like a tank, capable of diving faster than anything else in the sky without disintegrating. Robert Samuel Johnson grew up in Lawton, Oklahoma, population 18,000. He was 22 years old, stood 5'8", and weighed 165 pounds. Before the war, he'd worked in his father's garage, rebuilding car engines and learning that sometimes the strongest solution wasn't the most elegant. It was the one that simply refused to break. When he enlisted in the Army Air Forces in November 1941, 3 weeks before Pearl Harbor, he'd never been in an airplane. By March 1944, he was flying his 27th combat mission. The problem facing American fighter pilots in 1943 wasn't German skill, though the Luftwaffe veterans had plenty of that. It wasn't German numbers, though they still held air superiority over the Reich. The problem was physics. Between June 1943 and February 1944, 41 American fighter aircraft were lost to structural failure during high-speed maneuvers. Not shot down, not crashed. They simply came apart in mid-air when pilots pushed them past 450 miles per hour in combat dives. The official term was flutter-induced structural collapse. Pilots called it coming unglued. Wings folded upward, tail sections separated, control surfaces locked solid or tore completely free. When it happened, there was no recovery, no bailout time. The aircraft transitioned from functional machine to falling debris in less than 2 seconds. German pilots knew this limitation intimately because their own aircraft suffered the same flaw. Messerschmitt 109s and Focke-Wulf 190s could outturn and outclimb early American fighters, but push them past 480 miles in a dive, and they'd vibrate so violently the pilot couldn't see his instruments. Past 500 miles, control surfaces would flutter, then fail. Past 520 miles, the aircraft would begin to disintegrate. So both sides had an unspoken speed limit. You could dive to escape, but not too fast. You could pursue, but not too aggressively. The sky had an invisible ceiling of violence, and crossing it meant death. Lieutenant Danny Morrison knew this. Everyone knew this. Morrison was from Seattle, Washington. He and Johnson had met in flight training at Thunderbird Field in Arizona, discovered they were both mechanics' sons, both loved Fats Waller's jazz piano, both planned to open an auto repair shop after the war. Morrison and Johnson's garage 50-50 split, they'd shaken hands on it. Morrison flew wing position for Johnson in the 61st Fighter Squadron, 56th Fighter Group, the legendary Wolfpack. On February 8, 1944, over Frankfurt, Morrison's P-47C encountered a Messerschmitt 109G at 24,000 feet. The German dove away at maximum speed. Morrison followed, pushed his throttle forward, and watched his airspeed climb past 460 meters per. His aircraft began to shudder. At 480 meters, the vibration became violent. Morrison pulled back on the stick. It didn't respond. The flutter had locked his elevator. His aircraft nosed over steeper. 490 matches, 500 matches. Witnesses on the ground reported seeing the P-47's wings fold upward like a closing book before the entire aircraft exploded. Morrison was 23 years old. His body was never recovered. Johnson was flying 2,000 feet above when it happened. He saw the debris cloud, knew immediately what it meant, and felt something cold settle into his stomach. That night he sat alone in the barracks, staring at Morrison's empty bunk, thinking about structural limits and the unforgiving mathematics of high-speed flight. But Johnson was a mechanic's son, and mechanics don't accept that something can't be fixed. The P-47 Thunderbolt that Johnson flew wasn't like Morrison's earlier C model. It was a D model, and Republic Aviation had made changes that hadn't been fully communicated to frontline pilots because the engineering reports were classified and the field modifications were still being evaluated. What Johnson didn't know yet was that he was flying the most structurally overbuilt fighter aircraft in aviation history. The P-47D Thunderbolt weighed 10 pounds empty. Fully loaded with fuel, ammunition, and pilot, it tipped the scales at 17,500 pounds, nearly 8 tons. By comparison, a Messerschmitt 109G weighed 6,940 pounds loaded. A Focke-Wulf 190A weighed 9,735 pounds. The Thunderbolt was a monster, the heaviest single-engine fighter in the war. German engineers called it unmöglich, impossible. The aircraft was too heavy to be agile, too heavy to climb quickly, too heavy to turn with lighter fighters. By every principle of aeronautical engineering, it should have been a failure. But Republic Aviation's chief designer, Alexander Kartveli, hadn't been trying to build an elegant fighter. He'd been trying to build one that wouldn't die. The Thunderbolt's wing was 40 feet 9 inches across, with a semi-elliptical profile 27 inches thick at the root. Inside that wing were 3 main spars. Most fighters had 2, with additional reinforcement ribs every 8 inches. The wing skin was 40-inch aluminum, thicker than any other fighter's. The internal structure could withstand load factors of plus 12G and 5G. Combat loads rarely exceeded plus 8G. The fuselage was built around a massive engine mount that supported the 2 535 horsepower Pratt & Whitney R2800 double wasp radial engine and its General Electric turbocharger. That turbocharger sat in the rear fuselage, connected to the engine by thick ducting, and its placement there actually strengthened the airframe like an internal buttress. The entire structure was over-engineered by a factor of 2. Where 1 rivet was needed, Republic used 3. Where 1 structural member would suffice, they installed 2. Every single P-47D was stress-tested to 14G before leaving the factory. Kartveli's engineering team had calculated that if they built the aircraft strong enough to survive ground testing at 14G, it would never fail in actual combat conditions. They were right. But in early 1944, most pilots didn't know this. They'd been trained on the limitations of earlier fighters. They'd seen what happened to Morrison. They flew the Thunderbolt carefully, respectfully, aware that speed kills, aircraft as well as pilots. Johnson was different. On March 17, 1944, Johnson's squadron encountered a formation of FW-190s northwest of Schweinfurt. The German fighters immediately dove away, standard Luftwaffe tactic against the heavier American aircraft. They'd dive, extend their speed advantage, then climb back to altitude where the P-47s couldn't follow efficiently. Johnson dove after them. His airspeed indicator climbed past 450 mph. The aircraft began its familiar shudder. Johnson kept the throttle forward, 460 mph, 470 mph. The vibration increased, but it wasn't the chaotic, destructive flutter that killed Morrison. It was steady, predictable, the sound of a machine being pushed hard but not braking. Johnson dove steeper, 480 mph, 490 mph. The German fighters below him began evasive maneuvers, clearly visible now, well within gun range. Johnson's gun sight tracked the nearest FW-190. His finger moved to the trigger, 500 mm. At that exact moment, The German pilot looked back over his shoulder and saw the massive American fighter still closing, still under control, still diving. The Focke-Wulf's speedometer was showing 780 kilometers per hour, 485 mph, and the aircraft was already vibrating so hard the pilot couldn't read his instruments clearly. The American should have been dead, his aircraft in pieces. But the P-47 was accelerating. Johnson opened fire at 400 yards, 8 50-caliber machine guns, firing 800 rounds per minute each, a combined rate of 400 rounds per minute. The convergence pattern put all 8 streams onto a 3-foot circle at that range. The German aircraft staggered under the impact, rolled inverted, and went straight down, trailing black smoke. Johnson pulled back on the stick. The Thunderbolt responded instantly. The G-forces crushed him into his seat. Later calculations would show he'd pulled 2 Gs during that recovery. But the aircraft didn't flex, didn't groan, didn't hesitate. It pulled out of the dive at 800 feet and climbed back toward the fight. Johnson looked at his airspeed indicator as it wound down. The needle had touched 520 miles per hour. He was supposed to be dead. His aircraft was supposed to be scattered across the German countryside. Instead, he was climbing back to altitude with a kill confirmed and every system functioning normally. His hands were shaking, not from fear, but from understanding. He'd just exceeded the known survival speed of any fighter aircraft in service by more than 40 miles per hour, and his Thunderbolt had handled it like a training flight. That night, Johnson sat in the operations tent with his flight leader, Captain Gerald W. Jerry Johnson, no relation, and described what had happened. Jerry Johnson had flown P-47s since Tunisia, logged 14 kills, and knew the aircraft's reputation for durability, but this was different. "You're saying you dove to 520, Jerry said slowly. "Indicated airspeed," Bob confirmed. "Maybe more." The needle was buried against the stop, and the aircraft held together. Didn't even feel like it was straining. Jerry Johnson stared at the younger pilot for a long moment, then stood up and walked to the squadron technical library. He returned with a classified engineering report dated November 1943. A structural analysis of the P-47D performed by Republic Aviation and the Army Air Forces Material Command. He opened it to page 47, pointed to a graph. Maximum demonstrated dive speed, 550 miles per hour indicated airspeed. Structural failure threshold, not reached during testing. Recommended operational limit, 505 miles per hour, based on pilot tolerance rather than structural limits. "Son of a bitch," Jerry said quietly. "They built it stronger than anyone told us." The next day, Jerry Johnson briefed the entire 61st Fighter Squadron on Bob Johnson's dive. He showed them the engineering report. He explained that the P-47D's structural integrity exceeded anything the Luftwaffe could field, exceeded anything American pilots had previously flown, exceeded most pilots' willingness to test. "The aircraft won't quit on you," Jerry told them. "If you need to dive, dive. If you need to pull, the Thunderbolt will take it. But belief requires more than words. It requires proof, and proof requires seeing." Over the next 3 weeks, more pilots tested the limits. Captain Walker Bud Mahurin dove through a formation of Mi-109s at 515 MPH, firing all the way down, destroyed 2 aircraft, and pulled out with textbook precision. Lieutenant Leroy Schreiber pushed his P-47 to 530 mph, chasing a fleeing FW-190, caught it, killed it, and climbed back to altitude without his aircraft showing a single stress crack. Each successful high-speed engagement spread the word further. Pilots who'd been flying cautiously, respecting imaginary limits, began to realize they'd been granted an enormous tactical advantage. The Thunderbolt could dive faster than any German fighter could survive. It could pull out harder. It could absorb battle damage that would destroy other aircraft. Between March and June 1944, P-47 squadrons in the 8th Air Force recorded 673 aerial victories. 412 of those kills occurred during high-speed diving attacks that would have been impossible or suicidal in any other Allied fighter. The Luftwaffe noticed. Oberst Johannes Mackie Steinhoff, a decorated German ace with 176 kills, was shot down over France on June 18, 1944. Captured by American forces, he was interrogated by Army Air Forces intelligence officers. The transcript was declassified in 1973. Intelligence officer: describe your encounter with the P-47 units. Steinhoff: they dive like stones. Like nothing I have seen. We were trained that no fighter could safely exceed 480 miles per hour in a dive. The Americans exceed 500, perhaps 520. Our aircraft cannot match this. Intelligence officer: why not? Steinhoff: because at those speeds, our fighters destroy themselves. Flutter, structural failure, control lockup. The P-47 does not suffer these problems. Intelligence officer: did you develop tactics to counter this? Steinhoff: yes, do not dive away from them. Do not try to escape downward. They will catch you, and they will kill you. German technical intelligence captured a damaged P-47D near Aachen in August 1944. Luftwaffe engineers transported it to the Rechlin test facility, repaired it enough to examine its structure, and wrote a detailed analysis. That report, captured by Allied forces in 1945, described the Thunderbolt's construction as excessive to the point of waste, noted its weight as impossible for sustained combat maneuverability, and concluded that American industrial capacity allows construction methods that would be unthinkable for German production. What the report didn't say, but what the engineers understood, was that American pilots were flying aircraft they could trust absolutely. German pilots were flying machines that would kill them if pushed too hard. That psychological difference, the confidence to dive without fear, to pull without hesitation, was as much a weapon as the 850 caliber guns. By September 1944, the P-47's reputation for indestructibility had become legendary. Pilots routinely returned to base with damage that should have been catastrophic: cylinders shot out of the radial engine, entire sections of wing or tail missing, hydraulic systems destroyed, fuel tanks riddled with holes. The aircraft kept flying. Lieutenant Robert Johnson, the same Bob Johnson who'd made that first 520 Mamiha dive, flew his 28th and final mission on May 8, 1944. His P-47 was hit by German anti-aircraft fire and attacked by 3 FW-190s. He took cannon shells through the fuselage, lost part of his tail, and had his canopy shattered. He couldn't bail out because his parachute straps had been severed. So he flew the crippled Thunderbolt 200 miles back to England, landed gear up on the grass beside his runway, and walked away. His aircraft had 21 20mm cannon shell holes and more than 200 92-meter machine gun bullet impacts. Maintenance crews counted them. The aircraft was beyond repair, but Johnson was alive. The official Army Air Forces history credits the P-47 Thunderbolt with 3 752 aerial victories in the European theater and 3 499 in the Pacific theater. Those numbers include every variant of the aircraft. But the D model, with its strengthened structure and supreme dive capability, accounted for roughly 60% of those kills, approximately 350 German and Japanese aircraft destroyed. More importantly, the P-47 had the lowest loss rate per 1,000 sorties of any American fighter in Europe. 7 aircraft lost per 1,000 combat missions. By comparison, the P-51 Mustang, more glamorous, faster in level flight, more maneuverable, lost 1-2 aircraft per 1,000 sorties. Thunderbolt pilots had a 54% better chance of surviving their missions, but when the war ended, the credit went elsewhere. The P-51 was celebrated as the fighter that won the air war, sleek, beautiful, escorting bombers all the way to Berlin. The P-47 was dismissed as a jug, a brute, an inelegant solution to aerial combat. Fighter pilots wanted to be known for flying the Mustang. The Thunderbolt was the aircraft you flew when you couldn't get a Mustang assignment. Alexander Kartveli, the designer who'd created the Thunderbolt's legendary structure, received little public recognition. Republic Aviation won contracts, made money, built 15 636 P-47s, more than any other American fighter except the P-51. But Kartveli himself remained unknown outside engineering circles. After the war, he returned to designing aircraft for Republic. He created the F-84 Thunderjet, the F-105 Thunder Chief, and contributed to dozens of other projects. He died in 1974, aged 76, in New York. His obituary in the New York Times was 4 paragraphs long. It mentioned his work on the P-47 in one sentence. It did not mention that his structural engineering philosophy, build it strong enough that pilots never have to worry, had saved thousands of American lives. Robert Johnson returned to Lawton, Oklahoma in November 1945. He was 24 years old, credited with 28 aerial victories, recipient of the Distinguished Service Cross and 10 additional decorations. He never opened the garage he'd planned with Danny Morrison, couldn't bear to knowing his partner was dead. Instead, he worked for Republic Aviation for a few years as a test pilot, then quit flying entirely and became an insurance salesman. He gave occasional interviews to aviation historians. He always credited his survival to the P-47's durability, never to his own skill. "The aircraft saved me," he'd say. "I just pointed it in the right direction." He died in 1998, aged 77. His obituary mentioned his wartime service but focused primarily on his family: wife, 3 children, 7 grandchildren, successful insurance career. The obituary did not mention that he'd been one of the first pilots to prove the P-47 could dive faster than any fighter in the sky without tearing apart. It did not mention that his willingness to exceed the accepted limits had changed how an entire generation of pilots flew combat. There's a small display at the National Museum of the United States Air Force in Dayton, Ohio. It shows a cutaway section of a P-47D wing with its triple spar structure and reinforced skin visible. The placard explains that the Thunderbolt was one of the most durable fighters of World War II. That's all it says, one of the most durable. It doesn't say that German pilots feared diving away from P-47s because they knew the American fighter could follow them straight to hell. It doesn't say that Luftwaffe tactical manuals were rewritten specifically to counter the Thunderbolt's dive advantage. It doesn't say that thousands of American pilots owed their lives to an engineer who believed in building machines that refused to fail. But the statistics remember, between 1943 and 1945, in the skies over Europe and the Pacific, when American pilots needed to dive at impossible speeds, pull impossible G-forces, or survive impossible damage, they flew P-47 Thunderbolts. And the Thunderbolts held together, every single time. If this story moved you, if you're amazed that engineering and industrial might could create such a profound tactical advantage, hit that like button. Subscribe to this channel so you never miss another story of innovation and courage from World War II. Tell us in the comments, what's the most indestructible machine you've ever used? What have you trusted with your life? We want to hear from you. Thank you for keeping these stories alive. These men, these machines, these moments of excellence, they deserve to be remembered. Because somewhere in the forgotten corners of history, there's always another Danny Morrison who never came home, and another Bob Johnson who lived because someone decided to build something that wouldn't break. July 26, 1944, 2:47 p.m. 12,000 feet over occupied France near Évreux. Lieutenant Michael "Mickey" Gladish pulled his P-47D into a hard left turn, tracers from 3 Messerschmitt 109s stitching the air around him. His engine was already trailing smoke from the first pass. A 20mm cannon shell had punched through 2 cylinders of his radial engine. In any other fighter, he'd already be looking for a place to crash land, but this was a Thunderbolt. Gladish wasn't American, he was Polish. Michael Gladish, he'd anglicized the spelling for his American squadron mates, was born in Warsaw in 1915. He'd been a fighter pilot in the Polish Air Force when Germany invaded in September 1939. He'd shot down 2 Luftwaffe aircraft during the 18-day campaign before Poland fell. Then he'd escaped through Romania, made his way to France, fought with the French Air Force until France fell, escaped to England, flew Spitfires with the RAF's 303 Polish Squadron, and finally transferred to the American 8th Air Force in 1943 because the US units were getting the new P-47s, and Gladish had heard they were indestructible. He was about to find out if the rumors were true. The 3 Me-109s had caught Gladish's flight of 4 P-47s escorting B-17 bombers back from a raid on Stuttgart. Gladish's wingman, Lieutenant Carl "Smoky" Stram from Billings, Montana, had already gone down. Gladish had seen the parachute, so Stram was alive, but captured. The other two P-47s in the flight had broken away to engage a separate group of German fighters. Gladish was alone, damaged, with 3 experienced Luftwaffe pilots coordinating their attack. The first 109 came from above, firing. Gladish broke hard right, felt the impact shudder through his aircraft. The second 109 came from his left, cannon shells walking across his wing. The third sat behind him, waiting for Gladish to make a mistake. Gladish's engine was losing power. His oil pressure was dropping. White smoke was now mixing with the black coolant line hit. His airspeed was bleeding off. The Mi-109s were faster, more maneuverable, undamaged. Every tactical advantage belonged to them. Except one. Gladish pushed the stick forward and dove. The German pilots saw the smoking P-47 pitch over into a near-vertical descent and assumed they'd won. A damaged aircraft diving away was a pilot trying to escape, hoping to reach Allied lines before his engine quit completely. They followed, confident, taking their time to line up killing shots. Gladish watched his airspeed indicator climb past 400 mph. His engine was still running, roughly, violently, but running. The Germans were following, 450 mph. The vibration from his damaged engine made the entire aircraft shake. 410 mph. The 3 Mi-109s were still behind him, slightly above, beginning to fire. 500 mph. The lead German pilot's aircraft began to flutter. At that speed, with combat damage and an asymmetric load from his ammunition expenditure, his Messerschmitt couldn't handle the aerodynamic forces. He pulled out of the dive immediately, climbing away. The second pilot hesitated, pushed to 510 mph, and felt his control surfaces begin to lock. He pulled out. The third pilot, younger, more aggressive or more foolish, stayed with Gladish. His Mi-109 was vibrating so hard he could barely see through his gun sight, but the American was right there, smoking, obviously dying. One more burst would finish it. Gladish counted to 3, then pulled back on the stick with everything he had. The P-47, despite its damaged engine, despite the holes in its wing, despite the smoking coolant and the oil pressure dropping towards 0, responded instantly. The G-forces crushed Gladish into his seat, 8 Gs, 9 Gs, his vision graying at the edges, but the Thunderbolt pulled out of the dive at 4,000 feet, curved through the bottom of the arc and began climbing. The German pilot tried to follow. At 9 Gs, with his aircraft already stressed by the 520 mm dive, the Mi-109's airframe failed. The tail section separated first, then the wings folded upward. The fighter disintegrated at 3,200 feet. The pilot never got out. Gladish leveled off at 8,000 feet, alone, his engine now barely producing 40% power. He was 180 miles from his base at RAF Boxted in England. His oil pressure gauge was reading 0. His engine temperature was in the red. White smoke was streaming behind him like a banner. He nursed the dying Thunderbolt across France, across the Channel. The engine finally seized completely 15 miles from the English coast, the massive radial locking solid, propeller windmilling uselessly. Gladish glided the last 13 miles, cleared the cliffs of Dover by 300 feet, and dead-sticked the P-47 onto the grass beside an RAF emergency field near Manston. The aircraft slid 400 yards before stopping. Gladish climbed out, kissed the wing, and counted the damage. 87 bullet and cannon shell impacts, 2 cylinders of the engine destroyed, coolant system ruptured, oil system destroyed, elevator control cables partially severed, right aileron with a hole you could put your head through. The aircraft had flown 180 miles, pulled 9 Gs, and glided 13 miles with a dead engine, and delivered its pilot alive. The maintenance officer who inspected the wreck shook his head. "This thing should have come apart in mid-air," he said. "How the hell did it hold together?" Gladish, who spoke English with a heavy Polish accent, smiled. "Because his Thunderbolt," he said. "Thunderbolt does not break." That night, Gladish wrote a letter to his sister in London. She'd escaped Poland with him in 1939. In it, he described the day's combat, then added, "The Americans build their fighters like they build their buildings, strong enough for any storm. The Germans build elegance, the British build tradition. The Americans build survival. I think the Americans understand war better. Gladych flew 56 more combat missions in P-47s. He was shot down twice more, once by ground fire, once by an Me-109 that caught him at low altitude. Both times he walked away from the wreckage. He finished the war with 10 confirmed kills, though he claimed 18, a distinguished flying cross, and an unshakable belief that the P-47 Thunderbolt was the finest fighter aircraft ever built. After the war, Gladych couldn't return to Poland. The Soviets had occupied it, and his wartime service with the Western Allies marked him as an enemy. He stayed in America, became a U.S. citizen, and worked as a mechanical engineer in New York. He never spoke much about his combat experience. When asked about the war, he'd say, "I was lucky I had a good aircraft." He died in 2011, aged 95, in Cornwall, New York. His obituary mentioned his service with 3 air forces and his survival against impossible odds. It mentioned his engineering career and his family. What it didn't mention was that moment over France when he'd trusted a damaged aircraft to pull 9 Gs at the bottom of a 520-meter dive, and the aircraft had trusted him back. There's a photo of Gladych's P-47 after that July mission, taken at the emergency field near Manston. It shows the massive radial engine with 2 cylinders blown out, holes through the cowling, the wing damage, the tail riddled with impacts. Standing next to the aircraft, Gladych is smiling. Not the grin of victory, but the quiet smile of a man who understands he should be dead and isn't. That photograph hangs in the Polish Air Force Museum in Krakow. The placard beneath it is in Polish and English. The English version reads, "Captain Michael Gladych with his P-47D Thunderbolt, RAF Manston, July 1944. Aircraft sustained 87 combat impacts and engine failure. Pilot survived." What it doesn't say, what the museum visitors never know, is that this moment, this impossible survival, happened because 15 months earlier, an engineer named Alexander Kartveli had decided to overbuild everything, to use 3 rivets instead of 1, to use 3 spars instead of 2, to make the aircraft so strong that even when it was dying it refused to kill its pilot. The mathematics of survival aren't elegant. They're brutal, simple and effective. Build it strong enough that nothing can break it. The P-47 Thunderbolt was that mathematics made real. 10,000 pounds of aluminum, steel and radial engine that simply refused to fail. And because of that, pilots like Mickey Gladych came home.